Okay, today we're going to look at the inverse matrix. So first of all, if we think about what is an inverse, so say I had the number 3, the inverse of 3 is actually 1 over 3. And say the inverse of 2 would be 1 over 2. So the way another way of writing 1 over 2 is actually 2 to the negative 1, or here we could say 3 to the negative 1. So this becomes a way of writing the inverse, so to the power of negative 1. And if you have a look at it, if I had a number, say I had a number 9, and I times it by the inverse of 3, in a sense what you're actually doing, so you're timesing it by a third, but you can see you're actually dividing by 3. So if I took the number 9 and I times it by the inverse of 2, what I'm doing is actually like timesing by a half, but it's actually like, say, we're dividing by 2. So timesing something by the inverse is like dividing by that number. And that's just a handy little thought to remember when we're trying to do some problem solving with matrices. So if I have, say, I have a matrix, say matrix C, and I want to divide it by matrix A, well, in a sense, I can't, well, what I could write it like this, so C divided by A, but we can't do that in matrices. So what we will do is we will times by the inverse of A. So, and we can't, and in the inverse of A, we can write that like to the power of negative 1. All right, so it's a good fact to remember, and it will help you with the problem solving. So the next thing we're going to look at when we're looking at the inverse is also if you times something by the inverse of itself, so say 3 and I times it by its inverse, which would be 1 over 3, I end up with, it's like 3 over 3, which equals 1. So the same if I times 2 by its inverse, I'm going to end up with 1. So that's the same similar thing with matrices, is that if you times a matrix by its inverse, so if we have matrix A and I times it by its inverse, so really it's like saying A over matrix A, you'll end up with what we call the identity matrix, which is like a number 1. So an identity matrix, remember, is it has to be a square, and we're going to see that. So this is the other important fact about inverse matrices. Inverse matrices can only occur if the matrix is square. So say, for example, you'd have a 2 by 2 or a 3 by 3 or a 4 by 4, etc. And so you can only have a square matrix with an inverse, but not all matrices will have an inverse. Even if it's square, it doesn't necessarily mean it will have an inverse. There's some other things. So in this next example here, it says show that the matrices A and B are inverses. So really what we're going to say, if we call this matrix A, they're saying that B is the inverse of A. So really it would be A to the negative 1. So because we know if we times something, a matrix, by its inverse, we should get the identity matrix. So what they've done here, you can see there, here's matrix A and here's matrix B, and they're timesing it together. So if we think about our manual multiplication, so if we have run and dive, you can see the 6 times a third plus the 3 times a negative third. And then they've done the next, say this number, which was, this column, this row by this column, and that's there. And then they've done this row by this, which is this one, and then that by that, and here. So when they do all those calculations, we see we've got the identity matrix where we have 1s on the leading diagonal and 0s everywhere. else. Okay, so therefore we know that B is actually the inverse of A. Okay, so we could do this on our calculator where I show you this was matrix A here, and I raised it to power of -1, and so this is what the inverse looks like. And so if I times A by its inverse, you can see I get the identity matrix. So we're going to move on now. Okay, so what we do need to do is we do need to know how to manually find the inverse matrix of a 2 by 2. So here you can see if we have a 2 by 2, we're going to have 4 elements in that matrix, or 4 numbers. So if you look here, we've got these 4 numbers in the matrix. So the first thing when we look to find the inverse is we're going to have to learn how to find this part of the inverse, which is called the determinant. And the determinant is simply because we only have to manually know how to find the determinant of a 2 by 2. You simply take the number that's in that A position and you times it by the D, and then you minus it by the B times the C. So say for example here, this example A, if I was finding the determinant of matrix A, which they're saying is 3, 4, 2 and -3, when we go to find the determinant, they obviously say det. We might write it as the determinant det A. So it'll be 3 times the -3 minus the 4 times the 2. So we end up with -9 minus 8, which equals -17. So that's where they go. When they find the next one, the determinant of this one B, they're doing 6 times 2 minus the 3 times 2. So there it is, and it equals 6. And then the last one here, where they did 4 times 6 minus 8 times 3. So we end up with 24 minus 24, which is 0. Okay, so taking a look at that, we can see that the determinant of a matrix can be both positive or negative, or could be 0. But we do have this case when it is 0, it's known as a singular matrix. So you might just want to take note there. A singular matrix is when its determinant equals 0. So before I mentioned that not every square matrix will have an inverse, and a singular matrix does not have an inverse. So you can see if it's singular and the det equals 0, no inverse can be found. Okay. Alright, so now we've worked out how to do the determinant, we can go find out how to manually work out the inverse. So we only have to manually work out how to find an inverse of a 2 by 2. So once again, we're going to have this matrix, this 2 by 2 matrix, which has 4 elements. And the way we go to find the inverse, so because they've called this one A, I might call the inverse, so I'll say the inverse A. It can be found by going 1 over. Now, you'll notice in the formula, it is A times the D minus the B times the C. So you can see we know that there is the rule for the determinant. So we could write, that's why here they're writing the rule as 1 over the determinant. Yep. Hi.
I'm struggling with the first question. I've been sitting here for 20 minutes to try and figure it out.
Alright, let me share screen so I can see what you're doing.
Yeah. Okay.
Alright, so I've got it open. 12A, this one?
12A, B, and C.
Oh, there's
1B, C.
B and C, yeah. All right. Okay, and then we will flip these two numbers get swapped around. So you see the D comes up here and the A comes down here. And the other numbers, the B becomes negative and the C becomes negative. If they're already negative, you will then just make that a positive number. So if you're making a negative number positive, a negative number negative, it'll become positive. So in summary, you can see that that's why they write 1 over det, because this part here is the rule for the determinant, and then they'll just write that we've swapped these two numbers around and that we've made this negative. So if I walk you through this example here with the matrix A, they're going to, if we go to find the inverse, so it's going to be 1 over, now it's A times D, so it'll be 0.8 times 0.7 minus the B times C, so 0.3 times 0.2, okay? Now we're going to change these ones around, swap the spots, so we end up with 0.7 up there and 0.8 down here, and then we're going to make the other ones negative 0.3 and negative 0.2. So if you do this point, if we calculate this number, we end up with 1 over 0.5. So we're just simplifying that down. And then what you're essentially doing is you're timesing each, that's like a scalar multiplication. So you end up with, really what you're doing is you're saying 0.7 over 0.5, negative 0.3 over 0.5, negative 0.2 over 0.5, or 0.8 over 0.5. And then obviously you work that out on your calculator and you end up back here. This is the inverse of matrix A. Alright, so if you have a bigger matrix, bigger than a 2 by 2, so what we're saying, if you have say a 3 by 3 or say 4 by 4, etc., any bigger, we'll just do it on our calculator. So if we want to find, say, the determinant of A, okay, what we can do is type the letters DET into our calculator, a curly bracket, and then you type out the matrix and press enter, and you'll end up with your determinant, which ends up being 16. You'll see 16. So if we wanted to find the inverse of A, all you have to do on your calculator is just type in the matrix and then raise that matrix to the power of -1. And you do that and you'll see you get this answer. They've stored it. They've stored the original matrix. I don't see the need to do that. You can just do them straight on your calculator. All right. Okay, so with this example 4, it says the determinant of this matrix is equal to 9. So if we were finding the determinant of that matrix, remember we're going to say this spot times that spot, so it'll be 3 times x minus the 2 times 6, so 2 times 6. So we'd get 3x minus 12. Now they've said that's equal to 9, so I can say 9 equals that. If you're not very good at your equations, you can always use your solve function on your calculator. Otherwise you can solve this equation and it'll end up being x equals 7. Okay, so there's that answer. Now, in this one here, it says consider matrix A and A is equal to this. And down here it says if A is equal to its inverse for which particular value of K. Alright, so really what you need to do is think about this statement here. A is equal to its inverse. So if this is A, then its inverse is exactly the same because they're saying they're equal. So it means the inverse looks exactly the same because that's the only way that matrices are equal, is if they look exactly the same. So they're saying they equal each other. Now we know, what do we know about a matrix and its inverse? So we know from earlier on, we know if we times our matrix by its inverse, we get the identity matrix. So what we're saying here is if I take matrix A, so I'm calling this A, which is 3k, -4, -3. If I times it by its inverse, when in this scenario is exactly the same, I must get the identity, which is going to be a 2 by 2 as well, with the ones on the leading diagonal, like that. So when we know this fact, or we write it out like this, we can see we can work it out. Because if you see, this spot here can be found, now that's in row 1, column 1, so it's found by going like this row by this column. So what we would actually be doing there, here, it would be 3 times 3 plus k times -4, and they're saying it equals 1. Sorry, k times -4. So I end up with 9 minus 4k equals 1. And if you can either, if you're not very good, you want to just go to solve here on the calc, that's fine to work it out. Or you'll see that k ends up being -8 divided by -4, so k equals 2. So we find out that k equals 2, and there's the answer. Okay, so example 7. A and B are square matrices such that if you times A by B, it's the same as B times A, and that's the identity. So because they've said if you times, because they're saying if you times A, matrix A, by matrix B, you will get the identity. So what that's saying, telling me that really I could say that matrix A, I could say that this matrix B must be the inverse of A, because we know if you times them together, if you times a matrix by its inverse, you get the identity. Okay, so if you remember back to what I said, if I just had any number, so if I times a number 2 by its inverse, which is a half, we get 1. So this is pretty much what this statement's saying. So over here, they're asking me which one's not true. So you could just, to make your life easier, you could just think about real numbers. So if I had 2, now remember B's the inverse. So 2 times the inverse, back times 2, it would give 2. So this statement's true. If I look at this one, so remember if A was 2, remember B is the inverse. So it would be 2 squared times 2. So you end up with 2 times 1 over 4 times 2. It does equal 1. So this statement's true. The next one, it says that B must equal A. We know that is not true. We know that B is the inverse of A. That does not mean it's equal. They will look different. It's just the inverse. So this one's not true. And if you look at all the other statements, B is the inverse, yes, and both A and B have inverses. That's true because you can get an inverse. You wouldn't be able to get an inverse. All right.